Okay, now let's do question number 1 of practice 5.2. We need to write the reaction mechanism for 2-methyl butane. So as we have seen in example 5.7, the answer is having to produce this product. And first we need to do step 1, initiation. Initiation is when Br molecule is being transformed into 2Br free radical. What happens is the UV light is going to be used to form homolytic cleavage here, whereby one electron is going to be transferred to bromine. Each of them would have one unpaired electron, becoming a free radical of bromine. And then we have propagation is the second step, whereby the bromine free radical will attack this compound. CH3C. So we have this bond there. Okay, CH2, CH3. What happened is the free radical will attack this bond and it will abstract hydrogen. So this compound is going to have one free radical. So what happened is CH3, this is going to form CH3C Br, and then CH3 CH2 CH3 together with HBr. Sorry, this is what is going to happen here is the free radical. Okay, next I'm going to write again the free radical here. What type of free radical is this? Classification of this free radical is tertiary free radical, and it is going to attack another bromine molecule, and what happened is the same. One electron is going to be transferred to one bromine atom, and then the final product is going to be formed. CH2, CH3, and also bromine free radical is going to be formed. So this 1 and 2 reaction is going to go on until termination step is happening. So now let's do the termination step. There are 3 reactions. Reaction number 1 is involving the free radical of bromine. It is going to form bromine molecule back. Okay, and then the second free radical. The second reaction is going to be involving the free radical of tertiary and bromine radical. So we are going to form the major product over here. Okay, and then the third reaction is going to produce a longer alkane. As you can see here, we are using two tertiary free radicals. Can you imagine what is going to happen here? This is really interesting, as it's going to form this part is going to be attached to the free radical over there. Let's name this minor compound of halogenation of alkane. So this is a substituent, this is substituent, this is substituent, and this is substituent because this is a longer chain. 1, 2, 3, 4, 5, 6. So the name for this compound is 3, 3, 4, 4 tetrahexane. That's it. So you're going to get at least 9 marks for reaction mechanism of free radical substitution. Now the second question is for us to do question number 4 in example 5.7. The compound is this one, where we have a quaternary carbon. The thing is, the quaternary carbon is already filled with 4 methyl group attached to it. So we cannot attach bromine at carbon in the middle anymore. I chose just now the first carbon on the left. If you choose the carbon on top or on the right or at the bottom, you're going to produce the same molecule. Try name them if you don't believe me. Now, let's do the initiation process first. Initiation. Sorry. Of course, it would be the homolytic cleavage of bromine molecule using UV light. So we are going to produce 2 Br free radical, and then the propagation step would be this reactant that we have. We are going to have CH2 over here and 1H. The weakest bond is going to give its electron unpaired there, and then we are going to have this becoming the free radical. Now the type of free radical is a primary free radical because this particular carbon is attached to only one carbon. So HBr would be the side product. Now, the second reaction is that the primary free radical is going to be neutralized by the reaction of homolytic cleavage of a molecule of bromine, whereby the free radical now is going to be formed by the bromine molecule. So Br CH2. So this is the middle carbon. This is the methyl attachment, and then Br dot. So this Br dot is going to do this reaction again, and it is going to propagate continuously until we do a termination step. Basically, it's not a termination step, it is 3 reactions. So Br dot will react with Br dot to become Br2, and then the free radical that we have just now, CH2C, CH3, CH3, CH3 plus Br dot. This is going to produce the major product that we have previously in example 517. And then this is the interesting part, where we are going to produce a longer alkane, but this is the minor product, so the percentage of it being produced is minimal. Now we're going to do the CH2C, and then CH3, and then the CH3 here, and then a CH3 here, and then another part that's the mirror image of it, CH2, C, and then CH3, CH3, and then CH3. So this is the compound, and let's name this alkane. I'm circling the substituent. There are how many carbons? 1, 2, 3, 4, 5. So that is 5 carbon. If we count from here, 1, 2, 3, 4, 5. Yeah, it's also 5. 1, 2, 3, 4, 5, 6. Oh, if we count it like this, it's going to be 6. So I'm cancelling the first one here. 1, 2, 3, 4. Oh, sorry. It's the same because I miscount this one. So sorry. 1, 2, 3, 4, 5, 6. Yeah, it's hexane. So 2, 2, 5, 5, tetrahexane. Tetra what? Tetramethyl. Tetramethyl hexane. So let me count again. 1, 2, 3, 4, 5, 6. Yes. 1, 2, 3, 4, 5, 6. Yeah, it's going to be 2, 2, 5, 5. However we count the carbon. So that's it for practice 5.2. Okay, let's do question number 2. Cyclopentane. Wow, cyclopentane is this one. How are we going to do free radical substitution on it? Suggest the product form when cyclopentane reacts with chlorine gas in the presence of light. So when we react cyclopentane with chlorine. So chlorine is there, and then UV we must have that, and we are going to put 1 chlorine attached to chloropentane. We're going to produce chlorocyclopentane. Name the type of reaction in A. Of course, it is free radical substitution. Okay. Write the mechanism for the chlorination of cyclopentane and state the observation for the reaction above. The observation would be brown color of chlorine gas turns to colorless. That is the observation. So now let's do initiation process. Initiation start. So it would have a chlorine gas, UV, and we get 2 chlorine. This is the arrow, the half-headed arrow, which is important. That shows only 1 electron is transferred. So it become chlorine. Free radical. Propagation step is when you have the what is this? I always draw this as the shape of Superman. I put H there, and then it is attached to chlorine free radical. So I'm giving it a half-headed arrow like that, and then I'm going to produce the cyclopentane free radical over there together with HCl. Now the second step would be that cyclopentane free radical is going to do the homolytic cleavage on chlorine. So it's going to become the major product, which is chlorocyclopentane together with chlorine free radical. Okay. Now termination has 3 steps. Okay, step number 1 is chlorine free radical plus chlorine free radical become chlorine molecule. And then the step where we have the free radical of cyclopentane with Cl minus, we are going to produce cyclopentane chlorocyclopentane. And finally, this is the interesting part, where we are going to add together 2 cyclopentane. So it's going to become, let's draw it closely. Yeah. Okay, this is attached to the second, I think it's like this. Yeah, it's like that. Okay, so it produces chlorine, and then chlorocyclopentane, and this is bicyclopentane. Okay, so doing the reaction mechanism for free radical substitution is not that difficult. It's very interesting once you understand what is going on. So I've shown to you 4 examples of the mechanism. I hope you would be able to do it on your own after this.